This video on the channel Blocks Bonds Funds is created for educational and informational purposes only and does not constitute financial or investment advice.
Welcome everyone! Today we're going to break down Ethereum, but we're not going to talk about it as just a currency. We're going to look at it as a single global computer, a machine that's fundamentally changing how finance and maybe even computation itself works.
All right, here's our game plan. First, we'll look at the problem Ethereum was actually built to solve. Then, we'll dive into its core identity, this idea of a world-state machine. After that, we'll look at the nuts and bolts, the transactions and accounts that make it run, before putting it all together to see this whole incredible system in action.
So, to really get what Ethereum is all about, we have to start by understanding what came before it. We need to look at the limitations of the first generation of blockchains and see why the world needed something way more programmable.
You see, Bitcoin has its own scripting language, but you can think of it like a very powerful but very specialized calculator. It's designed for one job, securely transferring value, and it does that brilliantly. But it's deliberately limited. It can't do things like loops as a safety measure. And crucially, it's stateless. It doesn't really have a persistent memory of past events. Ethereum's goal was totally different. It was designed from the ground up to be a general-purpose computer. It's Turing-complete, which is a fancy way of saying it can run pretty much any program you can imagine. And most importantly, it's stateful. It has a memory. It remembers what happened before, which is the key to building complex applications.
And that statefulness brings us to the single most important idea in this entire explainer. The best way to think about Ethereum is not as a chain of blocks, but as one single global computer. A computer that operates as a transaction-based state machine. At the very heart of this world computer is something called the world state. The easiest way to picture it is as the computer's one and only hard drive. It's this massive, shared database that contains the current status of everything on the network. We're talking every account's balance, every piece of code for every application, and all the data that's ever been stored. Now, what's really amazing is that the entire operation of this global computer boils down to this one simple process you see here. Ethereum just moves from one state to the next. You start with the current world state, right? A transaction comes in, that's the input. That transaction is applied to the current state, and what comes out the other side is a new, updated world state. That's it. That's the whole system in a nutshell. State, input, new state.
Okay, now, I know this might look a little intimidating, but it's really just the elegant, mathematical way of describing exactly what we just talked about. All this formula says is that the new state is the result of a function that takes the old state and applies a transaction to it. This isn't just for show. This is the unbreakable master rule that ensures every single computer on the network all around the world arrives at the exact same new state. It is the absolute source of truth.
So, if the world state is the hard drive, and that function is the ironclad rulebook, what actually tells the computer to do anything? Let's talk about the inputs that kick things off and the processor that does all the work.
The inputs are transactions. But we need to get rid of the idea that a transaction is just for sending money. On Ethereum, a transaction is a signed command. It's an instruction. When you send a transaction, you're telling the world computer to execute a task, to run a specific function, to save a piece of data, or to deploy a whole new program. Every single transaction is a request to change the state of the world. And the processor that runs all these commands is the Ethereum Virtual Machine, or EVM. You can literally think of the EVM as the CPU for our world computer. It's the execution engine that lives on thousands of machines globally, and its one and only job is to take transactions, process them, and calculate the next valid world state.
Now, the EVM has three absolutely critical properties that make it all work. First, it's deterministic. This means if you give it an input, it will always produce the exact same output, no matter where in the world it's running. This is non-negotiable for consensus. Second, it's isolated. It runs in a secure sandbox, so a smart contract can't just start messing with your computer's files. And third, it's what we call quasi-Turing complete. It's powerful enough to run any program, but, and this is the genius part, every single computational step has a cost. This is the safety valve that prevents the infinite loops that other systems were so worried about.
Okay, so we've got our hard drive, the world state, and our CPU, the EVM. Now let's talk about the users and the actual programs, the applications that run on this world computer.
On Ethereum, there are two different types of accounts. On the left, you have externally owned accounts, or EOAs. This is your account. It's what you, a human, control with a private key. And here is the most important part. Only an EOA can start a transaction. On the right, you have contract accounts.
These are the applications themselves. They don't have a human owner, they're controlled entirely by their own code. And they can't do anything on their own, they can only react when a transaction from an EOA calls them into action.
And that brings us, of course, to smart contracts. So what is a smart contract really? At the end of the day, it's just a program. That's it. It's a bundle of code with its own private storage that lives at a permanent address inside the world computer, waiting for someone to call it.
And this is where all that programmability comes to life. These smart contracts are like autonomous agents. They define rules, they automatically execute actions when certain conditions are met, and they can control valuable assets without needing a bank or a lawyer or any other middleman. All the complex applications you've heard about, whether it's DeFi, NFTs, or something else, it's all just if this, then that logic running inside one of these contracts.
All right, we've covered all the components. We have the state, the EVM, the different kinds of accounts, and the smart contracts. So now, let's put it all together and watch the entire system work from start to finish.
Okay, so let's trace the full life cycle. Step 1. It all starts with a user, you, using your externally owned account to create and sign a transaction. Step 2. That transaction gets broadcast out to the network, where it's picked up by the EVM on thousands of computers. Step 3. The EVM executes the instructions in your transaction, which might involve calling a function inside a smart contract. And finally, step 4. The logic in that contract runs, and the world state, our global hard drive, is updated with the final results. A balance changes, some new data gets stored, and the next state of the computer is officially locked in.
So if you only take one single thing away from this entire explainer, let it be this. Ethereum is not just another blockchain or another cryptocurrency. It is a deterministic computation engine. It's a global machine specifically built to update the state of money and assets, all through the power of programmable, unstoppable logic.
But this raises a huge question. If this world's computer can run any program at all, what stops a malicious one from just running forever and grinding the entire system to a halt? The answer is that every single tiny computation has a price tag attached to it. That price is called gas. And that's exactly what we're going to break down in our next explainer.